Hello, hello. Hi Divya, welcome to the chat. Welcome to the stream. Okay, so welcome back to the streams, Java Streams API, learning journey. So as you guys already know, this is the series in which we are looking at the Java Streams API, and we are in level 5 now. Yeah, let's cook some more streams. And this is part 10 of the whole Streams API playlist, or like the series, and this will be probably the second last item. So there will be one more part. No, there will be one more part. So if you see the notes right on the right side, so today we'll cover 1 to 5, and in the next part we'll cover 6 to 10. Yeah, thing is, this what do you say, level 5 looks easy for us now, because they are actually reusing all the stuff that we studied in all the first 4 parts, right? So I'm assuming that we'll be able to do it fast if we let's take it as a challenge and do as many as possible. Okay, let this live stream run for 2 hours, and we'll see how much we can do. Okay, we'll cover as many as possible and finish it and move on to the next one. Okay, fine. So let's move on. So first, housekeeping stuff. I actually committed whatever I did so far. Okay, so I was lagging in that. Whatever is there for so far with the streams, I have committed it to the GitHub repo. Questions are in the main branch, and answers are in the, what do you say, this thing, solutions branch. Okay, so the GitHub link is there in the video description. You can take it from there and work with me. Okay, so let's start L5 assignment. First problem. Okay, so read the question, try to understand it. I'll prepare the whiteboard meanwhile. Okay, so I hope you guys read the question. It's pretty small. Given a large list of integers, calculate the sum of squares using parallel string. Okay, so what they're asking is, the question has a list of integers like 1 2 3 4 5, and they want to find the sum of all the squares of the values. Okay, so let's say we get 1 square, 2 square, 3 square, 4 square, and 5 square, right? You have to find the values of these, and you have to sum them together. Okay, and if you add this, I don't know what's the expected value, 55 apparently. Okay, so they want the final value, which is 55 if you add all of this. Okay, that's it, simple as that. So can you give the solution? Okay, how many arguments does reduce operation take? I see you have return numbers.string.reduce I to I star I. How many operations does reduce take? Oops. 2. Okay, so first thing, it takes 2. The next thing is, I'll say what your answer, I mean your solution does. So you said stream, right? Numbers.stream, and then what are you doing? Dot reduce I to I into I. Okay, so even if you said so like let's say a comma b as a into b, even in this case what it will do is it will do 1 into 2 into 3 into 4 into 5. This will be the answer, right? So that is not what we want. We want 1 square plus 2 square. So we can kind of tweak this. We need sum. Yes, we need sum of them. Sum of the squares even. So what do we do? Okay, so I'll explain the approach. So first thing what we need is they're asking squares, right? So if we, so this is wrong answer. I'll just strike it off. Okay, reduce 0 to integer of summing. That's a nice thing. So you're saying reduce and then you do 0 comma integer. So is there even a operation like this? I didn't know that. Okay, summing, and then you say I is I into I. I don't know if this is possible. Okay, let's keep this as option 1. Maybe I you just guessed. Okay, fine. So one thing is when you give a method reference, right, you can't pass arguments like this. It should always you know just, it should just be the function name. You can't say what to do with the arguments. That's one thing. Okay, fine. So let's try approach 2. Okay, fine. Maybe you wrote pseudocode, but anyways, let's try approach 2. So what I'm thinking is simple. You take a stream. Okay, then you map the values. Okay, so you have to map to int because then only you'll get the sum function. So in map to int, what I'll do is for every I, I'll map it to I into I. Okay, then I'll do sum. This should work, right? Because you are converting everything. So for example, 2 will be converted to 4, 3 will be converted to 9, 1 will be converted to 1 itself, and so on. And then you call sum on it. Then it will become 55, the sum of all the numbers that we got, right? Okay. So let's see if we can do it with reduce. I'm not sure. Let me see. So if we were to do it with reduce just for the fun of it, I think we have to do it. Not at all needed. Yeah. I mean, that was not the first thing that came to my mind, but let's see if we can reduce it. So it will start with 0, and then for every a comma b, we will reduce it to, I was thinking like this, a into a plus b into b. But this will also not work is what I'm guessing, because every time it will take the previous value. What's b? B is the current value. So reduce takes 2 inputs, right? So I will show how reduce works in this case. Okay, so let's just take 3 values. Okay, 2, 3, 4, and I'll call reduce on it. Okay, so when I call reduce, the first instance of reduce will take these 2, and that becomes a and b. So 2 comma 3 becomes 2 into 2 plus 3 into 3. Okay, in the first reduction operation. So this will give what? 4 plus 9, which is 13. Okay, so this will become 13. Now the next reduce operation, right? So reduce runs on the full thing. So next reduce operation, it will move from here to this will also be gone. So the pointer will move to here. So this will become b. 4 will become b. What is a now? A will become this reduced value 13 comma 4, right? Correct. But the problem here with my formula, what did I do? A into a plus b into b, right? So I see that it will become 13 into 13 plus 4 into 4, which is not what we want, right? We need 3 into 3 plus 4 into 4. So this reduce also doesn't work for us. So I think the simplest option is to do this, right? If you do this, we'll get the answer. So let's do that. Okay, so I'll do map to int. Okay, and for every value I will map it to value into value. Okay, and then I'll do sum. That's it. So this will give int sum equals this, and I'll return sum. Okay, so let me call the test case. Right, this test case, right? Run as JUnit test. So if any of you guys are finding it hard to follow, just drop it in the chat. Okay, what is difficult to understand, just drop it in the chat. We will explain it further. Fine. So with that, question number 1 is done. They asked to do it in parallel. Oh yeah. So how do you convert this into parallel? Correct, that's it. So instead of stream, you just invoke a parallel stream. Sorry, parallel stream. That's it. So all you had to change was this. Convert the stream to parallel stream. And if I run the test case now, it will still run. So it might look like just a simple thing for, you just convert stream to parallel stream. But for this test case, it's that much. Or like for this use case, it's only that much, because we are not doing very heavy, list manipulation or something like that. But where concurrency is needed, like modifying a list or like adding items to a list and things like that, then we have to make sure that we are video paused. Oh, now it's back. Okay, fine. So if we are doing heavy manipulation on data structures like list or something, in that case, parallel stream, we should make sure that concurrency is, handled. As in, if multiple threads are trying to manipulate a list by adding numbers to it or something like that, then our parallel stream will fail, right? So we should get like a concurrent, like a thread safe list and things like that. So that is the only thing we have to make sure when we do parallel stream. Okay. So with that, question number is done. Thank you for reminding me that it's parallel stream. I forgot. Okay. So let's move to the second question. Okay. Can you explain this part once again? Last part. You mean about parallel streams? So if I do a normal stream and parallel stream in this specific question, right, there is nothing going to be different. Correct. So in threads, what happens is, let's say I have a list which gathers the square of these numbers with example maybe. Okay, so let's take a question of this input is there, right? I want to get the square of those numbers and add it to a new list. That's it. Okay, so I hope you understood that. So I want a list of integer which should have the values these 1 4 9 16 25. Okay, okay, so this is what I want. Now what will I do using the normal thing? So also remember, I'm taking a very extreme example where you have to start, create your own just the squares, don't submit. Okay, so I will create a very square result equal to new array list. Okay, now I created a array list. Okay, now what I'll do is numbers dot stream dot for each. Okay, for each value I will add square result dot add value into value. Okay, so just make sure, let me know if this makes sense. Okay, so I can do dot to list and get the value, but I'm not doing that. I am intentionally adding this to a list outside the stream. Okay, so this makes sense, right? So if I try to print this now, let's say I do sysout and square result. If I print square result, okay, let's run this. Okay, you will see the output came 1 4 9 16 25, which was what I wanted, right? Fine. Now if I convert this to a parallel stream, what do you think the answer will be? The answer can be anything. So one thing is the order changes. That is not our main concern anyway. The other thing is you might not see all 5 values. Okay, might not. I don't know. I can't guarantee. Let's see. 5 values came. So I need even a bigger stream. That's the problem. Or I need to run it multiple times until I see the thing that I'm looking for. Let's do one thing. Okay, I will do a okay, so yeah, order change in the output, but that doesn't matter. So why order is changing is because whenever any of the thread in this parallel stream gets an output. So let me run this once. Okay, let me run this. So if you see here, 9 came first, which means that 3 square got computed first. So 5 threads got spawned. Okay, and 3 square is the thing that computed the output first, and it added the answer to our result set. Okay, then 25 5 square got computed next, and it got added. So 1 square was not the first thing that completed, right? Because it's in parallel. So 25, and then 4 square got computed, 1 square got computed, 2 square got computed. Okay, so that is why we see the order changing. What I am trying to demonstrate is when there is a race condition happening, it is even possible that this list might not have the updated values. Okay, so I'll try to explain what I'm want to explain. Okay, so let's say this is the result list. Okay, this is the result list which is empty for now. Okay, now 5 threads spawned, right? So 1 2 3 4 5. Okay, so 5 threads spawned for each number. Okay, now let's say 3 square got computed, and it added the value here. Okay, and it added the value as 9. Now every thread has access to this list, right? Every thread has access to this list directly. Okay, and the list is not synchronized by default. It is not a concurrent list. So what happens whenever someone else looks at the list, right? Let's say this 5 square got computed next. Okay, and it is trying to add to the list. Okay, it might not have even seen that this 9 already came here. It would have seen the initial list. Okay, so what it will do, it will simply add its value here, like 5. That is not correct, right? So when that happens is where the problem arises. So if we don't maintain concurrency, it will simply take a fake copy of the result list and update 5 here. So in the final result we might just see 5 and, the 5's value, what is it, 25 16, like that. So the 9 might have missed totally, because the thread which was having the 5 square, right, it didn't see the correct. The result may not be 1 on 1, which means the result might not be what do you say, you can't say it as a valid, like genuine answer, because these threads are accessing it at random. They are not synchronized. So this is a totally completely different concept when you go with multi-threading. So the simple solution to this is you can get we can have duplicate values in the result. No, we can't have duplicate values for this operation also, because every stream every thread is trying to push its own value only, so it will never be duplicate. It will either miss something. Yeah, the only thing that can happen in this case, it will just miss something. Let's say if you are having a set or something there, maybe, yeah, even then duplicate. I don't think for this use case we can demonstrate duplicate. So even in this one we can demonstrate this kind of inconsistency happening. Maybe if I add 100 or 1000 numbers, then we can try and see that might happen. But otherwise I don't know how to demo it. Do you want to like add maybe 10,000 numbers and see if we are having a square result dot size should be equal to the 10,000? Should we try that? Do you want to try that? Correct, only order will change. Try range. Okay, okay, so int stream, right, dot range closed. Okay, 1 to 1000. So this already creates a stream, so you can't invoke a parallel stream on that. That is the first thing. So I am thinking what you have to do first is you have to do dot for each. I will add no. Okay, first I'll push 10,000 items to the. I will never use range close. I'll simply add present. No, that is not very neat. Okay, so I'll do that first, and what I'll do is square result dot parallel stream. Okay, I'll say large input set. Okay, is this, and then I'll say large input set dot parallel stream. Okay, now square result, I'll create another list for that. Okay, fine. Now I'll just print the size of square result. Okay, we are not worried about the values in it. Okay, so what is happening here? Large input set. Okay, so first I initiated a large input set with 10,000 numbers in it. Then I initiated square result set, and I am putting all the square values of the values in large input set into square result. Okay, let's run this. Okay, let's see, only 5,600 items are there. Where are the remaining 5,600 items? So you see the problem? Not 5,000, so 4,400 items just vanished. There should be 10,000 items, right, in this square result list. Okay, so how do we solve this? So to solve this, I think there is something called collections dot thread. There is a synchronized list. Okay, and you say new array list. Okay, fine. If you do this, you got a synchronize. How can anybody trust parallel streams? Parallel streams is really good. It's not a problem with parallel streams. It's a problem with concurrency. You are not handling threads properly, so you can't blame parallel stream for that. So the solution is this: you have to use a synchronized list. Okay, so when you use a synchronized list, and let me run this now. Okay, now you'll see all 10,000 items are there. It's guaranteed. I see only uses when checking something like any match, etc. It's not like that. See, even here I can use parallel stream, but I have to use a synchronized list. That is the only catch here. So since we are using a collection, we can use synchronized list, and this is fine. But let's say square result was not a collection. Let's say it's one of our own data structure. Then we have to make sure that we synchronize it properly. Got it? So that is the only catch. As in, we have to make sure that, yeah, the collection that we are using is synchronized. Okay, fine. So this was kind of a quick short deviation that we took to understand what is the caveat with parallel stream. Okay, is it mutable? What is mutable? Yeah, this is mutable. That's why we could add items to it, right? So this synchronized list is mutable. Yes. Okay, cool, thanks. Fine. So I don't know if shall I leave it commented here just for people to understand, or maybe they'll have to watch the stream. This will confuse them. Okay, I'll just remove this. Okay, please add a comment. Okay, fine, then I'll keep it. So intermittently your video getting blurred in between for a few seconds, not a problem, but just letting you know. Yeah, I think something is going wrong with the, so overall my home internet, something is going on since evening when I came back home. I think I need to restart the router. But anyway, as long as the stream is fine, I am happy. If camera is getting blurred, I think it'll get back to it. Thanks for letting me know. Okay, so to understand the caveats of using parallel stream, I have demonstrated this use case below where I want to the square 10,000 integer. Okay, fine. So I hope below where I want to values and store it in a normal array list, but if we then that is okay, fine. Okay, thank you. So moving on to the next question. I will add this also up here. So here, how can we be sure that sum includes all numbers sum? So here, so one more thing. If you see here, I did this extra stuff, right? Okay, I'll come back to this again. What happened here? One second. So if you see here, I went over and beyond the collections or like streams inherent operations to go and create a synchronized list myself, right? But let's say I just did map here, okay, and do dot to list here. Okay, this itself will give you what I wanted. So let's say list of integer, default list. Okay, what happened here? List of boolean. Oh, sorry, this should be value into value. Okay, okay. So this default list by default will have concurrency. So if I print this one, right, let me run this. See, it had 10,000 items. So if I did a collector here, that will have the expected answer anyway. But my whole point was, if you are using, oh, BGM a little loud. So my whole point was, if you are using a separate thing of your own, okay, then we'll have to minus 45. Okay, I hope this is fine. So we have to make sure that that is synchronized, whatever data structure that we are using. Okay, that was the whole point. So is that clear? If you see here I used the default dot to list collector, even though I use a parallel stream. That will make sure that the values are collected properly, everything is concurrent, everything it will take care. But if I use a data structure outside the stream, because this I initiated it explicitly myself, then I have to make sure that it is synchronized, because inside the stream everything is synchronized, but if anything is outside that, you have to make it synchronized. Okay. Okay, so I hope you understood that. Let me undo. Cool. Yep, the more you know. Okay, so now we can move to question number 2. Okay, fine. So read the question, try to understand it. Let me prepare the whiteboard here meanwhile. The more I realize I don't know much. Yeah, I know, right? Okay, uh, try to you know, put your own solution if you understand the question. Okay, or else I'll write the solution. Let me have some water. Okay, so I hope you guys read the question already. Let me explain the question. So they're saying numbers dot parallel stream dot filter x is x mod 2, find first or else -1. Beautiful. Yeah, that is the answer. Okay, so let me explain the question. Good job. So let's they have given a list of integers, okay, and they're asking you to find the first item that is even. Okay, so stream goes this way, right? So they say 1 3 5 8, and 8 is the first item, so they want the answer as 8. Okay, this is the output. Now they're saying if there is no even number, let's say they gave a list where there is no even number at all, okay, then in that case they want us to return -1. Okay, that's the only thing that we have to take care. One more thing to note here is, Divya, you have mentioned parallel stream, to use parallel stream, right? But I don't think parallel stream will work here, as in is the correct answer here, because parallel stream will find any of this. Let's say there are 4 2 4 6 8 is the question, right? Then it won't always guaranteed return 2 as the answer, but our question asks for the first even number, so it should go in a linear way, right? So yeah, so instead of parallel stream you have to use stream. Okay, so that's the only thing you have to remember. Okay, so I hope the approach is clear. So the approach will be whatever Divya has mentioned. You have to first of all run a filter, to filter out all the items that are even. So you have to you do a is even kind of function here, and then you have to do find first. Okay, and what will find first return? It will return an optional value, optional integer. Okay, so when you have an optional integer, what do? You get the value of that integer and run dot or else on it, so that if there is no value, it will return whatever you say in or else. So you give -1. So question is wrong. So does it say to use parallel streams? It doesn't say to use parallel streams, right? Only the first question mentioned specifically to use parallel stream. Okay, fine. Okay, I thought the whole file is for parallel stream. No. So this is like a mixed bag of, because it's level 5, it's a mixed bag of a lot of things. Okay, so what we'll do, filter, numbers dot stream dot filter, and then what is the predicate? For every number we check if number is even, which means when you divide by 2, the remainder should be 0. Okay, and then you do dot find first. Okay, fine, and we return that. Oh, then we have to see if it couldn't find anything, you return -1. Okay, I'll return this and I'll run it. Let me make it look neat. Okay, first test case run as JUnit, it passed. Okay, and the second test case, so in the second test case the numbers they have given is 1 3 5 7 9, so there are no even numbers here. So when we run it, it will return -1, which is the expected answer, and it passed with that also. So Divya, I see you are using unary operators. Let's not do that. Let's not get into deep waters. So we'll just use the normal modulo. Okay. What is that? X is x ampersand 1 equal to 0. How do you even come up with these things? I don't know. Okay. So when we look into competitive programming with what is it, bit manipulation and unary operators, we will look into it. Okay. Oh, you learned some time back. Nice. Interesting. Fine. Okay. So this was pretty much it. Simple question. Hope everyone understood. If you guys have any doubts, drop it in the comment. Okay. We'll move with the third question meanwhile. So try to understand the third question. Okay, so I'll explain the third question on the whiteboard. They have given a list of integers and they're asking to simply find the maximum. Okay, in this case, what is the maximum? 20. Okay, so they want to look for the maximum value 20. Now they're saying if the list, so the only way you cannot find maximum in a list is if the list is empty. So let's say they gave you the question as an empty list. Okay, what is the maximum here? Nothing. It will be like empty. It's not null, it's actually empty. It will be empty. So when it happens empty, they are saying you have to throw an exception. Okay, now they didn't specifically mention what exception. Oh, they want to throw a no such element exception. Okay, 10 10 10. What is the maximum? 10 will be the maximum, right? Because there is a value. So even if you give one number 10, the maximum of 10 is 10 only. Okay, so the only use case where you cannot find a maximum is if the result set is empty. There is no value inside the list. They gave you an empty list and asked you to find the maximum, then there is no maximum. Okay, fine. So in that case, they are saying to throw a no such element exception. So this is the first time we are seeing this kind of throw an error kind of thing. We were always asked to return a default value if the value is not found, but throwing is the first time we are doing. Okay, right. So we'll do numbers dot stream. Okay, dot first we have to do map to int okay, then you do integer int value. Okay, and then you do dot max. Okay, this gives an optional int. So here is where we have the thing. So or else throw, right? So you have this or else throw, and this is what will throw your exception. Okay, so I'll return this. Okay, so I think when there is no element in the numbers, it will already see. So or else throw, if a value is present, returns the value, otherwise throw no such element exception. Okay, as simple as that. So they don't want us to let's say if there is no element, I don't want it to return -1 or anything else like that, right? I want instead for it to throw an exception itself. Okay, that is the only difference we saw here. So in the previous one, if you see, we are returning a default value of -1, but in this one, if you see, we are throwing the exception itself, the no such element exception. Okay, I'll run the test case. If you guys have question meanwhile, just let me know. Run as JUnit test. That passed. I saw it in this one. No, I saw one more test case. Let me see that. Test find max or throw. This one. Okay, I think this is what I ran now, but anyway, I'll run it again. So there can be only one test case for this, because you take an empty list and try to find the maximum in it, and if it's not there, you throw an exception. How to throw custom exception in there? There or else throw array index of bound. Yeah, nice question. Let me check because I don't know. Let me see. So there is or else throw and there is a supplier option. If a value is returned otherwise throws an exception produced by the exception supplying function. There is this overloaded function where you can supply exception. So I think this will you know uh, satisfy what you asked for. Let me see. Oh, this phone. Yeah, Zoom finally came back. Oh, this worked. Okay, you tried it already. Good thing. So let's say this and okay, interesting. So if I run this, I think it will fail because it would accept, yeah, it will accept a no such element exception, but we got a array index out about exception. So according to the test case, it failed, but the thing that we were trying worked, as in it threw an array index out of bounds exception. Okay, good question and good analysis. Okay, so I'll remove this because that is what is needed for our test case. Hey, where did it go? Oh, I did it. I didn't do this. Oops. Okay, fine. So with that, I guess the camera went off again. It'll come back slowly. Okay. So with that, question number 3 is done. Okay. Yeah, thank you. Question number 4. Generate sum of. So we are already at 4th question. How much time did we take? It's just 46 minutes and we are at 4th question. So I think we can complete all 10 today. Let's see. Okay, let's do that challenge. Fine. So int stream range. Generate sum of numbers from 1 to n. That's it. Okay. Yeah. Okay. Read the question. Understand it. Okay, I guess you guys read the question. It's a short question only. So all they're asking is, if you are given a number n equal to 10, then you are supposed to find the sum of everything from n to 1 to 10. Okay, so you have to find like 1 plus 2 plus 3 plus up to 10. Okay, I think the value will be 55. That is what is 10 factorial, right? So you have to find that. No algebra. I see you are doing n into n plus 1 by 2. No, not what is this called? Linear algebra or something? No, not like that. Okay, fine. So you're supposed to do it using streams. It's not algebra. Okay, fine. Okay. So how to do this? So they already gave you a hint here to use an int stream, right? So also when we saw the second question or first question, we saw how I generated the sample set of 10,000 numbers using the int stream. So we'll be using the same thing here to generate the numbers, and then we will add them. Okay. Int stream dot range closed 1 to n. Good. Fine. So we will use int stream dot range closed and 1 to n. Okay, so this function will give you a stream already. Okay, so on that stream we usually, if we have a list handle, we have to do map to int, but this is already an int stream, so we can simply do dot sum. That's it. 3 lines of code. Okay, so you return this. Fine. So I hope it is pretty intuitive already. So this int stream dot range closed will already give you a int stream. Okay, so you have a stream already. You don't need to do like dot stream on anything. Okay, and in that you give the numbers that you want to generate. So you want to generate from 1 to n. So for example, if they say 1 to 10, you generate 1 to 10, and then on that int stream you perform the sum function. Okay, and the sum is a collector, so it will just collect the sum and return an integer which is expected. So let's run the test case. So if I run this, run as JUnit test, it passed. Okay, so there is one more int stream, so I'll run this also. JUnit test, pass. Okay, so both test cases passed. Fine. So what does this change? Test from 1 to n small, but this has bigger. Oh, okay, 1 to 5. They tried 1 to 5 and expected 15. Okay, cool. So with that, question number 4 is done. And let's go to question number 5. Generate infinite stream. Okay, so yeah, read that question. Okay, I guess I hope you guys read the question. Oh, I figured out what was the problem with the zoom in. Oh, if you, okay, this is something unrelated to what you're studying, but if I press and hold and drag my fingers, then it sets the zoom level. So I think by mistake, I always set it to something wrong. Wow. So now I can do this. Oh, wow. Fine. Okay. Small distraction. Let me come back. So this question was, if they gave you an n is equal to 5, right? You are supposed to find out all the even numbers from 0 up till that number, right? From 0 up till, oh, it's not even up till that number. Oh, that is interesting. I thought it is up till that number. Okay, fine. Okay, so they're saying you generate an infinite string, okay, to 0 to infinity. Oops, that was a very bad infinity symbol. 0 to infinity, and then you limit it to whatever they said. So they said 5 numbers, right? So you will generate a 0, 2, 4, 6, 8, 10, 12, 14. Okay, it keeps going, but you limit it to the first 5 numbers because they gave n as 5, right? So 1, 2, 3, 4, 5, 0, 6, 8, and return this as our result set. Okay, that is what they are asking. So what ideas do you have to solve this? While true, what will you do with while true? While true, first of all, goes outside our stream cases, right? Because you need to stay in your stream. You shouldn't do while true. Then it becomes normal programming. Yeah. Okay. So there are two things I can think of. Okay. One is you have n, right? So, and they're asking even numbers only. So I can simply multiply this by 2. Okay. So I'll get up till 10, right? There is some new concept. Maybe. Okay, so I'll explain my approaches first, then we'll see if there are some new concept. Okay, so the first approach I'm thinking is you get n is equal to 5 into 2 and you get 10. So I'll start a range from 0 to 9. Okay, 0 to 9 I'll start a range. Okay, so end exclusive, so that you'll get 0 1 2 3 4 0 2 4 6 8. Okay, and then I'll do a filter and I'll get the even numbers. That is one I can think of. Another thing is you put the range as 0 till integer dot max value. Okay, integer dot max, and then integer dot max is a constant which is like the largest integer value you can have. Okay, I'll start a range on this and then I'll simply do a filter to filter even numbers. Then I'll say limit of 5. Okay, even in that case it will give you only 5 items, right? Still not infinite. You can't have infinite numbers in a JVM, right? So that doesn't make sense. Let's say they want to actually give n equal to infinite minus 1. How will they give here? The only thing they can do is integer dot max minus 1 is the only thing they can give, because that data type can't store anything more than that, right? Does that make sense? Okay. You're still thinking. Okay, fine. So question says infinite stream. Yeah, generate infinite stream, then limit to n. Okay, so let's see if the streams API has something like that. Okay, int stream dot range, right? Oh, here it is. So you were right. Returns an infinite sequential unordered stream where each element is generated by the provided int supplier. This is suitable for generating constant streams, streams of random elements, etc. Good. Okay, so we have to do generate apparently, and they are saying use a int supplier. Now what is this? Let's see. Generate. What is an int supplier? Represents a supplier of valued int valued results. This is the int producing primitive specialization of supplier. There is no requirement that a distinct result should be returned. So how do we use it? Okay. I am assuming you just say n is n mod 2 equal to 0 here. No, what is an int supplier? I think then you have to have some of this implementations. It doesn't have any implementation also. Okay, fine. Let's check this. What is this? Intstream.generate. How to use. Okay, they say intstream.generate method in Java is used. Let me zoom it in. Is used to create an infinite sequential and another stream of int values where each value is generated by an int supplier functional interface implementation. This is useful for producing random numbers, constant numbers, or any sequence that follows a particular pattern. So our pattern is even numbers, right? Now, this is a functional interface whose get as int methods supplies each stream value. So how to use it? So they're saying this is for generating a random number. So it's just a function. For a given pattern, it produces output. Correct. So if they're asking sequential integers, they're saying counter, get, and increment. So they are storing the so we should always store the state somewhere, right? Custom patterns. So we have to store the state somewhere. So what I understand from this is, let's say you want a random number in the generate. So if you want to create 5 random numbers, then you say that this is the int supplier. It supplies 5 as the number. If you want to make it a sequence of numbers, okay, if you want to give from, let's say, 0 to 4 is what they're trying to print, right? Then they are starting a counter, and then they are incrementing the counter inside the function. Okay, so that the state is getting stored. If they do not have a state, then when the generate function calls this again, it will keep returning 0, right? So that's why they are having a state outside called counter. So in our case, I think we need to have a counter, and instead of incrementing it once, we have to increment it twice, right? Makes sense. So let's see how it goes. Okay, let's try this. So in generate, I'll call atomic integer counter equals new atomic integer of, I'll start at 0. Okay, same. And inside this generate function, what I'll do is I'll do counter dot get and add 2. Okay, and then I'll do dot limit it to n, and then I'll do dot to list. Oops. And then I'll box it. I have to box it. They are asking a list of integers, so I have to box it and then do dot to list. Okay. Now if I return this, okay, this should return the thing. Okay, I mean list of even numbers. Okay, let's see if it works. Let me run the test case. Run as JUnit test. Yep, it passed. Okay, so that was the whole thing. Let me now ask to Perplexity if there is a better way to do this. Is there a better way to do it? Correct. So I see you're right, saying that get and add is a part of atomic integer, not stream. That is correct. So this is, so for those of you who don't know what atomic integer is, it's a it's an integer which is thread safe. So how we saw synchronized list is a thread safe list, right? Similarly, atomic integer is a thread safe integer. So if multiple threads are accessing atomic integer, it is always synchronized. Okay, that's the whole concept of atomic integer. And atomic integer gives us helper functions like get and add, or if you saw in Perplexity, it said this, right? Where is it? Get and increment. Get and increment will simply do a plus plus, like it will add only one. If you do get and add, it will add how much ever we are asking it to add. Okay, so when you do get and add for the first time, it will return 0, right? Because that is a first get and add. When you do get and add of 2 for the second time, it will return so it will return 0 and it will add 2 to the counter. Okay, when you do get and add for the second time, it will return 2 and then add 2 to it. So now the counter will be 4. Okay, when you do it again, it will do 4, and then so that is how it works. Okay, fine. So I just asked Perplexity whether if there's a better way with an intermittent burst, but it can be simplified using other instream methods that are more expressive and idiomatic. Oh, they are saying to use this x equal to x plus 2 and all, but that was not what we wanted, right? Right. So they are saying, what are you saying? Intstream. Yes, is correct. The only thing is it is returning the limit. I mean, missing the limit. Intstream.range closed. 1 to integer max value, filter it, and then you have to apply limit. Only thing missing is limit. So in that case, your answer is also correct. Okay, so they have given one more solution here, which we probably have to look into. So there is this thing called iterate. Okay, how do I? So there is this thing called iterate. So same like how we do generate, there is iterate, which also takes a pattern. Okay, and in this, it avoids the whole point of atomic integer itself. So you are storing everything inside the stream itself instead of keeping it outside. So let's try this also. Let me write it here. So int stream, int stream dot iterate. Okay, and seed, and then they're asking a unary operator, right? So seed is, it started with 0. Okay, and what is the unary operator? Unary operator is this. So for every x, do x plus 2. Okay, so for every x, do x plus 2. Okay, and then they are doing our limit of n, and then dot boxed dot to list. Okay, so if I did this, okay, this also generates up to how much ever infinity you want, right? But if you, so it, sorry, I didn't read. So it becomes linear, question mark. You mean linear as in, as opposite to parallel, correct? Yes, correct. In that case, even this is also parallel only. See here also, instead of atomic integer, I could have used like a normal int counter equal to 0 also. Okay, so the integer was fully thread safe and all. I could have even done like return counter plus plus, right? Oh, so it's just counter plus plus. Wait. Oh, this should have been final int. But then you can't do counter plus plus. Okay, so that was the whole point we used atomic integer. Okay, got it. So I thought we can simply use like a normal integer, int, like primitive int. What if I use a integer and then do counter dot add? No, you can't add. There is divide, max, min, percent, reverse, sum. Yeah, okay. This integer also doesn't have it. So, okay, so that was the whole point then why it suggested to use atomic integer. Okay, so this int stream is also not parallel, that is serial only. This int stream is also serial only. The thing was we used a separate counter variable, but with this solution we are simply generating the numbers to infinity in this case also, but then we are limiting it to n times, so it will run only n times. The only problem that I have, that I think, is with the solution that you have given, right? Or the solution that I first thought, right? The second one, second approach, is that I don't know if it will run, you know, max value number of times and then return only 5 items, or it will know that, okay, I have to run only 5 times, so it will not run up to max value time. I don't know about that. Right, that is the, okay, let's write that also. Okay, let's write all possible solutions. Okay, so int stream, okay, dot iterate. Now what was that? Range closed, right? Range closed. No, it's range. It's actually range closed only. No, range closed. 0 to integer dot max value dot limit n times, but you have to filter before that. So filter for every number mod 2 equals 0. Okay, limit it, box it, and convert it to list. Okay, this is also a solution. So I think all three returns the same output. Okay, fine. So this is solution 1, this is solution 2, and this is solution 3. So this is like the most brute force kind of. Please write short comment. Yeah, okay, I'll write a short comment. Most efficient, or I'll make the solution 3. Most efficient. Efficient spelling is wrong. Okay, ignore me. So most efficient solution with completely using what the method does. Which method? Most efficient solution completely using streams only. Short definition of iterate. Okay, fine. Generates a new number. Our iterate is called based on the given operation. Okay, so that is what this iterate does. Amen. Okay, so that is what iteration does. And for solution 2, or this is like what, solution 1. Okay, instead of adding at the end of each comment, I think you can modify the Eclipse configuration. Oh, yeah, probably, but I don't know how to. Yeah, I'll check that. That's a nice suggestion. Okay, fine. So solution 1, I'll put this at the first one. Solution 3, we will return this. Okay, and solution 2, solution 1 is not very good looking solution, but gets the job done. Okay, solution 2 is uses an external counter to maintain the state. Okay, and generate, what it does, generate calls the whatever this int supplier function every time a new number is needed, and the new number is obtained, new number state is maintained in the counter variable. Okay, good looking means not very good looking, because we are using all the 0 to integer or max value, so we are actually using a constant here. Whenever you use a constant, it's not very good looking, because you are not dynamic. This is not dynamic, right? We are hard coding the end limit here. It's not infinite. That's why I mentioned not very good looking solution. Make sense? Okay, fine. Okay, so let's run this. Oops. Open call hierarchy and run this. Okay, that passed. Okay, so just for completeness sake, let's see if our other two solutions also pass. Okay, I will return this. This is solution 2. Run. It passed. Okay, I'll run this. Solution 1. Okay, comment this one also. Run it. That also passed. Okay, so everything passed. Fine. So let me undo. Oops, undo. Okay, let me run it once again. Passed. Fine. Okay, so it has been more than 1 hour, 1 hour 15 minutes. Okay, and we have finished 5 problems. So shall we continue with the remaining 5 now and go as long as we can for the remaining 1 hour? What say you? We'll take a break and then we'll come back and continue the remaining 5. Let's take a quick look. Okay, let's take a quick look. So the 6th question is sum of string lengths. Example, given a list of strings, calculate total sum of all string lengths. So what they are having is, they are having 3 words and they want to, it's all new concept. If it's all new concepts, we can decide based on it. This is not new. This is you're calculating the length. Okay, so the next one, let's say convert intstream to list. This is also easy. You have to just use boxed. We already know it. Next one, 8th one, peak for debugging. This is new. Print and transform example. Given a list of numbers, print each number and then square them. Oh, this is not very complex, but we have seen this also. We have printed in between streams. So yeah, I think this is not very complex, but yeah, right. Okay, so 9th one, non-match. Check if no negative numbers. Given a list of numbers. Oh, this is easy. Okay, so you have to just say if there are no negative numbers in the given thing. Maybe there is another way, easy way to print. I think there is a, I have seen there is, when you do stream dot, it shows a peak function. I think that is what they're expecting us to do. But other than that, I don't think it does anything. So I think if you write stuff in peak, it won't run in production maybe. So if you can write as many sysout statements you want there for debugging on your local. Maybe that's what's the point of doing that peak. Yeah, we'll try that. Then the 10th question is, oh, there are 15 questions. Okay, I just realized it. So it's not 10, there are 10 more questions. So find any with parallel stream example. So they're saying given a list of strings, match any string that starts with J, either John or Jane should come. Okay, that is the 10th question. So we'll do 10 and then we'll stop. Okay, so the remaining five we will see in the next string. Fine. That makes this is also straightforward. Yeah, this is also straightforward. Okay, so when we finish this 10, we'll see. Okay, so we'll take a break now and we'll come back and see how it goes. Okay. You guys have this question set already. So in the break also, if you want to just go through the questions, yeah, and come back. Okay, let's take a break and we can finish the rest. Yeah, let's go. So I'll put a 10-minute timer and start the break. Okay, see you guys shortly. Hello. Okay, welcome back. Fine, let's dive in again. So let's start with the sixth question. Yeah, I hope you guys read the questions in the break if you guys had time. So yeah, read the question. I'll prepare the whiteboard. Okay, hope you read the question. Let me go back to the whiteboard. So what they're asking is, they have given a list of strings, okay, like hello world and Java, and they're asking us to, yeah, and they're asking us to find the length of each string, and it's essentially the sum of the length of all the strings. Okay, that's it. So um, this hello is of 5 characters, world is also 5 characters, Java is 4 characters, right? So what is 5 plus 5 plus 4? 14. So that's all they want. So they just want the output as the final sum of the sizes of each word. Okay, so how can you do this? Oh, awesome. Okay, so that was very short. So I see that we already answered. So how to do that is, you have in stream something called map to int, right? So with map to int, you can get the number. So what map to int number do you want? You want the length of each string, right? So you get the length of each string, and then you call sum on top of it, right? So you call this and then call sum on top of it, and you'll get the final answer, which is 14. Okay, so it's a simple one. Let's do it. Strings dot. So while I write this, can you think of if you can do this using reduce? Okay, how will you do this using reduce, for example? Okay, let me do this. So string dot map to streams dot map to int string length dot sum. Okay, this will already give us the answer we want. Let me run the test case. Run as unit test. Yeah, it passed. Okay, so with reduce, how will you do it? Can you guess it, or shall I try it? How? Okay, so okay, let me explain the approach first. Okay, so just like you are doing map to int and then doing the sum on it, what I will do manually is I'll take the length of each thing. So in the reduce operation, okay, or like, okay, first of all, let's get the length of each item with the map. Okay, so for every string, I'll map it to its length. Okay, now you'll get a string of numbers, right? Then I'll do a reduce. Okay, and in reduce, you can say you get two numbers, right? A and B. You can reduce it to A plus B. Now, how will this work? You'll have 5, 5, and 4, right? So when you do map of string to length, you will get the values 5, 5, and 4. Okay, and when you say reduce A comma B to A plus B, what it will do is the first A comma B will be 5 comma 4. Okay, will get reduced to 9. Then the next A comma B will be 9 comma, oh sorry, 5 comma 5. Sorry, 5 comma 5 will get reduced to 10. Then the next will have 10 comma 4 will get reduced to 14, and that will be the final output. Okay, so in reduce you can even give an initial value, right? So if you do that, for example, they say 0 comma A comma B, in that case what will happen? The reduce function will change to 0 comma 5. Okay, the first 5, that is. So this first 5 it will take, and it will do 5, and it will do 5 comma 5, okay, and it will do 10, then it will do 10 comma 4 and reduce it to 14. Okay, let's code it. Yeah, so strings dot map, stream dot map, I'll map everything to every string to its length. Okay, and then dot reduce, and I'll say for every a comma b, okay, make it a plus b. That's it. Should I say like that? Oh, and then I think that's it. So I'll return this. Okay, I'll comment this out. So we are actually doing, oh, what is this? Oh, it gives an optional integer. So I'll do dot or else 0. Okay, so if there is the list of string size is empty, they didn't give any string, then the or else will be 0. Okay, oh yeah, fine. Now I'll run this. That also passes. Okay, so essentially what I did here is I am manually doing the sum function instead of using the helper map to int function. That is the only change here, but this helps us like for us to understand how reducer works. Okay, so here also, if you can, you please write the initial value. Yeah, so if you write the initial value, I don't need or else because the initial value will be the one that will be returned. Okay, so this will be the answer for that. Okay, nice. Okay, so I'll using reduce operation, too much verbose. Okay, and this is using the what do you say, sum function that we get OOTB. Too much verbose itself is yeah. Okay, fine. Let's move to which question? 7th question. Boxed string. Convert an int stream to a list. Okay, given a range from 1 to 10, convert int stream a list of integers. So example is this and output is this, explanation is this. Okay, so try to understand it. I'll prepare the whiteboard. Okay, fine. So the question is, they will give you a start number and an end number. Okay, what you're supposed to do is construct a list out of it, list of integers out of it. Okay, so again, if you saw question number 1, I did the same thing, right? I took like 1 to 10,000 and I built a list of 10,000 numbers, right? So essentially the same thing we are going to do here. So they gave you a start and end. So what we'll be doing is we do this int stream, okay, and then do range closed. Okay, what does range closed do? It will include both the start and the end values. Okay, so it will create from 1 up till 5. Okay, we can't do dot to list directly on int stream. Correct. So we can't do dot to list directly on int stream because int stream generates primitive int this thing. Okay, in Java there is this primitive int data type, right? So it creates that. So we have to do what? We have to box it to the wrapper class integer. So to do that, what should we do? On the int stream itself, there is a function called boxed. This boxed function will do the boxing for us. Then we can simply do to list on that. Okay, that's it. So you'll get the list of integers. Fine. Okay, so int stream dot range closed start and end dot boxed oops dot to list. That's it. Okay, so let me run this. Call hierarchy. Where is it? Test intstream to list. This one. Run as JUnit test. Okay, that also passed. Fine. So they gave 1 and 5 as the start and end, and they're expecting a list of 1 to 5. Okay, 1, 2, 3, 4, 5, and we got that. Okay, so let's move on to the 8th question. So peek for debugging. So they're saying print and transform. Given a list of numbers, print each number and then square them. Example number is 1, 2, 3, and output expected should be 149, and it should also print processing 1, processing 2, processing 3. Okay, so the whole point here is they want to square the values. So why did I start explaining? Okay, try to read and understand the question. Is that a scared emoji? What is that? Oh, peeking. Okay. I see you have so much free time to send emojis. Okay, read the question. In horror, peeking in horror. Okay. So what they're asking is they'll give you this list of integers. You're supposed to square it and return the list of squared values. Your half strip. Okay. We'll end it soon. Okay. So we will square it and return the list of squared values. Now in between what they want is they want to also say like processing. I said printing by mistake. Processing 1, then they want processing 2, then they want processing 3. So whenever each operation is happening, they want to also do this. So it should print processing 1. Also the list should give like values 149. Okay, so it's just system.out.println to print these values. Okay, fine. So yeah, correct answer. You do map for doing the squares. And oh, I know, you know what. So let's see numbers per stream. Okay, so you do map. Okay, so map you'll do for every value. I'll value into value. Okay, simply write lambda x is sys out of. Okay. Yeah, that's a nice answer. Okay, let's do that. Okay, so in the lambda itself, you are suggesting that I'll do write this as a expanded lambda. I'll do sys out, and I'll print processing. What do they want? Colon space and then the value, and then they want us to return x into x, right? Value into value. Okay. I kind of had a glimpse of what you wrote and you deleted it. Okay, fine. So in here what we are doing, for every value we are returning the square of it. Okay, so how do so we'll just return this. So this will already give what we want as per the test case, the squaring. Okay, let me do this. Run as JUnit test. Okay, it passed. And if I see the std out also, it has processing 1, 2, 3. This also came. Okay, so one thing I wanted to see is I think there is something called dot peek. See, there is a peek function in stream which returns a stream consisting of the element of the stream, additionally performing the provided action on each item as the elements are consumed from the resulting stream. Okay, So it is also saying that it will perf- perform the provided action as well. Okay, you guys are chilling there. So how are they testing this out? I don't think they're testing this out. It's something we have to see. Yeah, they are not testing this out. Something we have to see in the console. Okay. So it's a replacement of stream. No, it's a replacement of map. So I think you can do this. No. Okay. Okay. So I'll do map again, and I'll show you the the definition of peak. It says it returns a stream of consisting of elements of the stream. Additionally, performing the provided action on each element as the elements are consumed from the resulting stream. That's what they are saying. So I don't know what that means. This method exists mainly to support debugging where you want to see the elements as they flow past a certain point in the pipeline. So they're saying they're giving an example also. Okay, let's read this example. How do I make this bigger? I can't. So they gave 1, 2, 3, 4. They're filtering it with whatever is greater than 3, and then they are peaking. Okay, then they are mapping, and then they are peaking again. So the whole point of this is to in cases where the stream implementation is able to optimize away the production of some or all of the elements, such as with short circuiting operation like find first, or in example describing count, the action will not be invoked for those elements. Okay, so what do you say? This is kind of a non-interfering thing. So what's going on there? Oh, it's a stream on top of stream. No, it's not. Which compiler to use? Java. Which is the best compiler? Yeah, that is what do you say? To be argumented. Argument. So I started with Eclipse. So what I'm using here is STS, which is a flavor of Eclipse. You can use Visual Studio Code, VS Code, or you can use IntelliJ as well. I think IntelliJ is good for understanding what is going on in the code and things like that. So you can try VS Code. I mean IntelliJ. But I think is it free? Divya is using IntelliJ. Is it free or paid? Is there a what is it? Community edition? I don't know. You have to check that. Okay. So peak. Why is peak failing? Because I have to do this. I'll just copy paste this. Okay. Okay, so what did we do here? So the thing about using peak is that we avoided messing up with our actual logic. So you see, we can keep the map function neat again, but in the peak we can write whatever debug function we want also. So that is one thing I noticed just now. So I will run and see the output. Also we got the output that we wanted. But one more thing they wrote in the peaks Java doc is that in cases where the stream implementation is able to optimize away. So whenever you want to optimize the stream, they are simply ignoring the peak call. So because of that, whatever is happening in the peak function, it will not happen. So which is a good thing, I guess. And so IntelliJ is good for newbies. Yes, community edition is free. Thanks. All the best on your journey. Thank you, guys. Thank you. Okay. Hope you come back to this advanced topic some days, after doing all the basics. So actually we are planning to do oops basics also as the next stream, and like interview questions, all of that. So you can subscribe if you want, if you're interested. When we do those streams, you can come and join us. Okay, fine. Thank you. Okay, so this question is done. If you guys have doubts on this one, we'll explain. Otherwise, we'll move to the next one. Okay. So ninth question, none match. Check if no negative numbers exist in the list. Okay, so given a list of integers, check if there are no negative numbers. Example is this, output is this, and explanation is this. Okay, fine. Read the question and try to understand it. Okay, clear? Okay, clear. There's a none match. Oh, there is an unmatch. I think so. Okay. I mean, we have used any match and all match, right? But I think there's an unmatch also, maybe. So this is a new thing for us. Okay, so let's go with the question. Let's understand it. So all they're asking is they gave a list of numbers, okay? And then they are saying that there shouldn't be any negative numbers. That's the question. So if there are no negative numbers, okay? No negative, you have to return true. And if there are even, if I write even, it becomes like even number. So at least one negative number, it returns false. Okay, that's it. So apparently, or maybe, I don't know, there must be a helper function, I guess, called none match in the stream. None match. Okay, so if none match is there, then in none match we have to say that none of it matches negative. Correct? Right. So I have to say that for every value is greater than or equal to 0, right? So if none of them, I kind of hate double negation. Can't see ID. Oh, I'm not showing ID. I'm showing the iPad. Can you see the iPad? I see my camera is paused. Something happened to the camera. Let me see what happened. Okay. Camera. Yeah, something happened to the camera. Ignore it. Fine. So no camera. Can just see your camera. Okay, I'll change it to my laptop web camera. Okay. I don't know how good that is going to be. Okay. This is your camera for today. Okay. Oh, sorry. I put my camera as the main stream. Okay. Back to this stream. Fine. So that was a question, right? So you understood the question, I hope. This is the iPad. So you see the question. So we are just making sure that nothing matches a negative number. Okay. Fine. Let's go back. Numbers dot stream dot none match. Is it a none? Oh, there is a none match. So returns whether no elements of this stream match the provided predicate. So the provided predicate should say you are looking for a negative number, right? So correct, that is the thing. So we say none match and make sure that num less than equal to 0. Okay, I think we returned. That's it. Okay, fine. Let's see. Let me run the test case. So test has no negatives. I'll run this. It passed. Then test has no negatives with negative. Oh, okay. There is a negative, and that also passed. Okay. So they put one number as -2, and it is expected to return a false value. Okay. Fine. So with that, ninth question is done. If you guys have a question, we'll go through it. Else we'll move to the 10th one. Okay. I'll move to the 10th one. If you guys have a question, let me know. Okay, find any with parallel string. Example, given a list of strings. Find any string that starts with J using parallel string. Okay, and this is the example. They gave these strings and the output is John or Jane. Any match because it's parallel. Okay, try to understand the question. Okay, let me explain the question. So they have given a list of words, okay? Alice, Bob, John, Jane, and Charlie. These words are there. Now they want us to return the word that starts with J, okay? Any word that starts with J, they want to return it. So it could either be John, okay? Or it could be Jane. And they want us to do it with parallel string, okay? Parallel stream. So when you are parallelly streaming, any of the stream could return a value, right? So you never know what will get returned. It could either be John or Jane, right? Because when you do a parallel stream, it creates multiple streams, okay? And the check that we are doing could pass for anything, right? So in that case, it could be either John or Jane, okay? Fine. So let's do that. Strings dot parallel stream dot filter. Okay, what do you filter? For every word or name, okay, every name, you see, name dot starts with prefixes J, okay, and you do dot find any, okay, and find any means it's always going to be optional. What if it's not there, right? So it's going to be an optional string, so we have to do dot or else and return an empty string maybe, okay. I will return this and remove this, okay. Read through the code once and see if you can understand it. If you guys have any questions, let me know. Can't we use any match here? We can, but they specifically mentioned find any. That is one reason I use this. We can use any match as well. So let's see if I used any match here, dot any match. And I can simply give this, right? Yeah, I can simply give this and I can remove this and this and this also. Why is this showing an error? Oh, any match actually gives a boolean, so it just says true or false. Oh yeah, yeah, you found that. I just realized it. Okay, so I have no any match. So there is a reason why there are two different functions. Nice. Okay, so let's test this. This one, right? Run as unit test. Okay, it passed. Fine. So with that, we completed 10 questions. And how long has the stream been running? 1 hour 57 minutes. Only 3 minutes is left. Okay, so should we bite the bullet and finish the remaining 5 questions, or since you guys are sleepy, should we do it tomorrow? Yeah, okay, Fine. So carry on. Have a good sleep. We will continue the rest of the questions tomorrow. Okay, there are only 5 left. So let me update this notepad. So we did 1 to 10 today. We will do 11 to 15 tomorrow. Okay, level 5. Okay. If they easy, let's finish. It's okay. We'll do it tomorrow because I don't know. They are easy only, but then I don't want to, do it in a hurry. So we'll do it calmly tomorrow. Tomorrow is anyway Friday, right? So we will finish this and we can maybe do even a late night stream of something else. Okay, if time permits. Okay. Okay then. Fine. So thank you all for joining. We will see tomorrow. So as usual, you guys can check the questions, whatever we discussed now in the GitHub. It's pinned in the chat and it's also available in the video description. Okay. So see you guys tomorrow evening. Tomorrow is Friday evening and have a good night. Bye bye.